All right, guys. So today we are verifying trig identities. All right. This is similar to what we did the other day where we were simplifying trig expressions. Okay? But now you're actually given the answer. You just have to show me how we can reach that answer. So in other words, you have to show me how this side of the equal sign is really equal to this side of the equal sign, or vice versa. Okay? It's kind of like a proof. Okay? I actually kind of think of it like a puzzle that you're trying to solve. Okay? I'm trying to figure out how to make this side look like this one by using some things that I already know. Okay? Yes, this is one of those things where I'm just a little bit off, that I think these are a lot of fun. Okay? Because it's like solving a puzzle, like a Sudoku puzzle or whatever it might be. You got to try and figure some things out based on what you already know. So, I enjoy them. Some of you will too. Some of you will hate them. I get that. All right, but we need to know what all the identities. We need to know all the identities that we talked about before break. Sine and cosecant, they're reciprocals of each other. Cosine and secant are reciprocals of each other. Tangent is sine over cosine.
Yep.
Cotangent is cosine over sine. Sine squared plus cosine squared equals 1. That was one of your Pythagorean identities. You had 3 Pythagorean identities. All those could potentially show up again as you're working through some of these. All right? So it's taking that knowledge, those identities that you already have, and trying to use that to help you show how one side of the equal sign is actually equal to another. This is another trig identity, except I'm telling you that this minus this equals tangent squared. You need to show me how it equals tangent squared. Okay? Here are my suggestions when you're doing these. Take the more complicated side, work with that one, and try and turn it into the simple side. Okay? So on this one, this side to me is more complicated because it has 2 terms. Here's a term, here's a term. So I'd work with this side and try to make this side equal to this side. All right? Then on this problem right over here, okay, you're like, well, they both look kind of complicated. No, I would agree. On this one, I would probably work with this side though, because I know how I can turn these things into sines and cosines. I would leave this alone, and I would mess with this side by changing them into terms of sines and cosines to make it look like that one. All right? So that's kind of how I decide which ones I want to mess with. Yep. When it comes to... Yeah. All right? So, I would strongly recommend writing these 2 examples down in your notes and showing the steps as I go through them. Okay? It'll give you a little bit of an idea of what I'm looking for when we're verifying these identities. Okay? Alright, so when I look at this one right here, I see I want my answer to be tangent squared. Okay? So somehow this over here has to equal tangent squared. Now, so I'm looking at this and I'm like, okay, well, it has some squares in it. I see some squares. Look back at your Pythagorean identities for a second. Do you see any Pythagorean identities that might have some of this already in it?
Yeah.
Which one are you looking at?
Tangent squared theta plus 1 equals secant squared theta.
So this is one of your Pythagorean identities. Okay? So look at this. You know this is true. This is one of your Pythagorean identities. Look at this, and look at what we have up here. Do you have an idea how we might be able to work with this to show how it is actually equal to tangent squared?
Didn't you say there was one that was equal to 1?
Sine squared plus cosine squared is equal to 1, yes. Yep. Can you see any relationship between this and maybe what we have here, or something similar? Tyler, what do you see?
I see that the tan x and the cotangent x, when you turn them into sine and cosine, they cancel each other out.
Okay, so he's kind of seeing how these 2 multiply together to make 1 in a sense, but how is that going to be helpful? How does that relate to this?
Well, turning that, well, if those equal 1, then having tan x squared plus 1 minus 1 would equal tan squared x.
So he's kind of pointing out that if you move the 1 over to the other side, you'd have tangent squared x equals secant squared x minus 1. Okay? And then he's kind of looking up here, oh, wait a minute, I see it. Because these two are going to cancel each other out and become 1. And then we know that secant squared x minus 1 is actually equal to tangent squared. Okay? So you got to use previous knowledge and kind of work with these a little bit and see if you can't make one side look like the other. Okay? So I would have recognized, looking at this, I would have thought, okay, I have a Pythagorean identity because I see some squares, and I know this is true. So let's maybe see if I can somehow get a 1 in here. So when I look at this, I think, okay, well, how could there be a 1? Well, these two things, I know they're reciprocals of each other. So maybe I would rewrite this side like this. Okay? When you guys think of tangent, do you think sine over cosine?
Yeah.
Yeah? Yes, no?
Yes.
Okay, you don't have to. And then cotangent is what?
Sine over cosine.
Cosine over sine.
Yeah.
Okay? Now can you see what's going to happen when I multiply those two fractions together? They're going to reduce to what? 1, right? Because cosine over cosine would reduce to 1 over 1. Sine over sine would reduce to 1 over 1. So now I have secant squared x minus, that's just 1, equals tangent squared x. Well, now isn't this, isn't secant squared x minus 1? Won't that equal tangent squared? So this part right here equals tangent squared, so I can replace that with tangent squared x. And that's the end. You have proven how this side is equal to that side. That's the end of your, that's the very last step you'll write. The very last step you will write in these verification problems is this is equal to itself. You're just essentially working your way down one of the sides until this side finally does equal that side. You have the exact same thing. That's what these verifications will look like. So you already know what the answer is going to be. You just have to use your previous identities that you know, work your way through them until at the very end you'll have tangent squared equals tangent squared. You might have 1 equals 1. Okay, who knows what, it just depends on the identity you're trying to verify. You only work with one side. Okay, you only work with one side, you keep the other side the same. Okay? What questions are going through your head right now? I know we've only done one, so, but what questions are going through your head right now? Okay, let me do another one. So here, I don't see any squares right now. So I'm probably not using any Pythagorean identities. If you see squares, I would think about Pythagorean identities like we did here. But here I don't see squares. Okay, so I'm not going to use my Pythagorean identities. What I'm probably going to do is I'm probably just going to change these guys into terms of sines and cosines so I can hopefully make it look just like that. That will be your logic a lot. Change everything into sines and cosines to make it look like the other one. Alright? So let's change this side into sines and cosines. Tangent is really what?
Cosine over
Careful.
sine over cosine.
Y over x, so sine over cosine. And secant is really what?
Reciprocal of cosine.
So 1 over cosine. Secant is the reciprocal of cosine, so 1 over cosine. Will you guys please ask a question if I say something that you don't understand so I don't keep going and lose you? I need... Does anybody have questions so far on this one? So I can explain it. We're okay? Okay. Alright. You don't need to write the other side of the equal sign all the way down if you don't want to. I'm okay if you just work with one side. But just don't change the other side. So now what? What are we going to do now?
Can't you do the reciprocal or something? You can add them together.
Can we add them together?
Yeah.
I don't even have to change anything, do I? I can add them together right as they are because they have what? Common denominator. Yeah, very good. I have fractions within fractions, so try to start to simplify that, okay? On the bottom, I have a fraction plus a fraction. Let's add them together, okay? And you're lucky here, they already have a common denominator. Sine over cosine plus 1 over cosine would actually equal what fraction? Sine x plus 1 all over cosine. For those of you that are forgetting how to add fractions, okay, if you would take 3 over 4 plus 2 over 4, you just add what's on top, right? It'd be 3 plus 2 all over 4, which, yes, is 5 over 4, okay? But because they have the same denominator, it's just sine of x plus 1 all over that common denominator, which in this case is cosine. Okay? So now I have 1 divided by a fraction. When you divide by a fraction, you actually multiply by the reciprocal. So when I take 1 and I multiply that by the reciprocal, cosine x over sine x plus 1, what do you get? Cosine x over sine x plus 1, right? And wouldn't you know, isn't that what we wanted it to equal in the end?
You multiply the top and the bottom by the
No, no, no. Okay? How do you do this? How do you take 4 and divide it by 2/3? What would you write? Anybody? 4 times
3 over 2.
3 over 2. Okay, that's how you divide fractions. You take what's on top and you multiply it by the reciprocal of the bottom. Right? Keep, change, flip, is that what you learned? Okay. So that's all I'm doing right here. I'm taking 1. That's nice. 1. Okay. And I'm multiplying it by the reciprocal of the bottom. So 1 times cosine x over sine x plus 1 would obviously equal cosine x over sine x plus 1. That help, Andy? Okay. Anybody else question on fractions? All your fraction work is going to come into play here. Making common denominators. Adding, subtracting, multiplying, dividing. Okay? And you don't really have a calculator to help you with it, so we got to be good at working with fractions here. Okay? Alright, so for the last step, if you don't mind, write that back in. Yeah, you don't need to write it every single time. It looks nice if you do, but if it's a complicated side, you don't necessarily have to. But that's just your answer. You're done. You have proven, you have verified that this is equal to this. Alright? Any other questions? I'll try and find a more complicated one here next and really try and challenge us. Yes?
Are you gonna ever do instances where it won't
Nope.
work out?
Nope, because the directions will be verified that this is true.
Okay.
So I'm not, unless I make a mistake, and give you one that cannot be verified, everyone's going to be able to be worked out. Yes. All right?